So we've got two outstanding issues with our moving platform. The first being that it tends to rotate freely like this, which makes it awfully hard to get the ball in the chute. The other is that every once in a while, our ball will somehow mysteriously pass right through the corner of our chute and not actually collide with it. Now, it turns out both of these issues are actually very easy to fix. So let's look at our code here and jump to our bonus chute. Now, you might suspect that if we want our chute to be at a particular rotation, we might have to apply some angular velocity the same way we're currently applying linear velocity. Maybe if our chute is less than 0 degrees, then we have to apply some positive velocity, and if our chute is greater than 0 degrees, we have to apply some negative velocity, and so on and so forth. And it actually turns out that this is an acceptable solution in some situations. If you were making, for instance, a Tetrisy-like game and you wanted the blocks to be able to rotate at 45 degrees or some arbitrary angle according to the user's whim, that might be one way you would do it. But in this case, basically we know that our chute just shouldn't be rotating ever. And so the fix is a whole lot easier. We can just go up to our chute body definition, and we can say chute body def dot fixed rotation equals true. And that's it. Simple fix, right? I mean, this is a case of like, chalk mark $1, knowing where to put it, $10,000. Look up the joke if you haven't seen it. So let's run this. And if I can hit the side of the chute. All right, look at that. Our ball is colliding with the side of the chute and it's bouncing off. And it doesn't look like our chute is any worse for wear. So, not bad. However, if you were paying attention in the sample application, and again, maybe you're noticing it on your application, there's a few times when it looks like my ball should have collided with the chute and it didn't. And let me explain why that's happening. Way back before I realized there were actual real physics engines out there, there were times when I'd try and mock up my own, and I usually did a terrible job. And one reason is I kept running into this issue. Let's say we've got a ball here, and it's moving at a very, very fast speed, and we are shooting it towards this wall. So our ball is moving at a fast speed, which means that, frame 1 it's here, maybe by frame 2 it's here. And then frame 3, if we follow the ball's current velocity, it ends up over here on the other side of the wall. At this point, maybe our system looks for collisions and says, aha, I found a collision. Our ball has collided with the right side of the wall. And to resolve that collision, our ball ends up somewhere around here. So our naive little physics world thinks that it has resolved the issue no problem, and it's put the ball at the right spot. It doesn't know that this ball should have collided way before it even got to the right side of the wall. And I think this is the issue that's happening with our application. We're running at a fairly low frame rate, and by the time these balls get to the bottom of the screen, the amount they move in one frame, or the amount they move in 1/30th of a second, is pretty far. And especially if we're looking to collide with these little corners of our bonus chute, I could easily see it missing it entirely from one frame to the next. Luckily, there is a solution for this. And it is when we create our ball, we specify the body with something called isBullet. This basically is sort of a flag that we set within a physics body that tells it, hey, this is a very fast moving object, and so you're going to have to detect collision a little more often than usual. In other words, even though our ball may end up at this further distance in frame 2, we're actually going to check at several points along the way to make sure that we haven't missed a collision. At least I'm pretty sure this is how Box2D is working. Maybe it's doing something even more clever than this. It could be. But if you think of it working like this, I think you'll still get the general idea. But going back to our sample problem, if we have decided that by frame 3 it's going to end up here on the right side of the wall, by specifying isBullet equals true, our engine is going to check at these intermediate points whether it's collided with anything as well. And this point will have caught the collision earlier before it's completely gone through the wall, and we will resolve the collision in a much better way, with our ball ending up here on the left side of the wall instead of on the right side of the wall. So one question you might be asking is, all right, well, if this works a whole lot better, why don't we set isBullet equals true all the time by default? And the answer, as you've probably figured out, is this is a lot more computation heavy than simply checking on a frame-by-frame basis. So you really only want to do this when you know that you have a fast-moving object that may be colliding with a thin object. In our application, that is exactly the case, and so it's worth taking the extra computation time to check this out. So let's go back to our application here, and I'm going to open up our ball actor. And when we create our ball body definition, oh yeah, see, I even marked it in code. One other thing I'm going to do here, I think I probably marked this like, about 20 lessons ago. Well, here's the time when I'm actually going to do it. I'm going to say ball body def dot isBullet equals true. And that's actually, again, all we need to do to fix this problem. If I run this, well, all right, so this might be hard for you to see, and I suppose my terrible aiming isn't making it any better, but it does look like our ball is now successfully colliding with the edges of this platform on the little corners when it wasn't before. So that's pretty good. I'm pretty happy with it. I suppose we can go back to making our application look a little more real by bringing back our pegs. And there we go. We now have an application with our pegs and our bonus chute. And at this point, I think we've covered almost all of the major areas that we want to cover in our Puggle application. I think probably the next thing that we want to do is check out that fun little zoom and slow down effect. Some of this is just probably basic flash camera stuff that maybe you're already familiar with. And some of it is looking at Box2D and using it to slow down time, which also happens to be fairly easy. So we'll cover that stuff next, and then maybe when we're done with that, we can finally add in the aiming line so that I can aim a little better in these things. So stick around.